Okay, this video is going to cover polarization. This is section 2310 in your textbook. We know that an electromagnetic wave looks like this. If we want to let the electric field be drawn in blue, the electric field as I'm drawing it at this point is oscillating up and down like this. And our magnetic field would be oscillating in and out of the board. But I'm not really interested in much of it. I'm just going to draw it here, something like this. Okay. The intensity of this electromagnetic field is given by I equals 1/2 epsilon naught E max squared. And remember this value right here, that'd be E max. Okay. If you have a situation where the electric field is oscillating only up and down in a direction that is parallel to the y-axis, we would call that a linearly polarized wave or light. Most light is not polarized. Most light would have the electric field oscillating in all different directions. But if it only can oscillate up and down the way we've drawn it, it's linearly polarized. This is an example of linearly polarized in the y direction. Okay. Now the direction of polarization is always the direction that the electric field is oscillating. It doesn't depend on the direction of the magnetic field. So if our electric field's only allowed to oscillate up and down like this, instead of in all different directions, which is more normal, we would have linearly polarized light. Okay. Most of the time when you have a light source, it is not polarized. If I think of this being a source of light here, or an electromagnetic wave, most of the time you would have a light oscillating up and down in the y direction, but also back and forth any direction that you could picture. You can think of this really as being three-dimensional, it'd be oscillating in every direction. Okay? To create polarized light, we use a filter discovered by the Polaroid company. That's where that camera, and that's where they got their name, Polaroid sunglasses. They're the ones that had not the copyright, what do you call it, for inventions, the patent on polarizing films. Polarizing films are made with these really long molecules, and the really long molecules kind of act like slits. So if you think about a slit like this on a microscopic scale, but let's think about it on a big scale. If I had a piece of plywood and I cut a vertical slit in it and I put it between me and another person, we could take a rope and shake it up and down, and the wave would travel right through this slit. But if the slit's vertical and I took my rope and tried to shake it in crossways, the wave couldn't travel through. That's exactly what a polarizing filter does. So you put a piece of polarizing filter here, and all of the waves that come through it are now polarized. The electric field can oscillate up and down, but it can't oscillate in any of those other random directions, okay? With a perfect polarizer, exactly 1/2 of the incident light is transmitted. So if I have unpolarized light like this, and it goes through a polarizing film, exactly 1/2 of the light will actually be able to be transmitted through that filter. Okay, that's one of the ways. We'll talk a little bit more about this, though, that polarized sunglasses work. One of the ways is simply by putting in a polarizing film. You're going to cut the intensity of the light that reaches your eye in exactly 1/2. The other way they work is the filters are vertically polarized. Well, most glare, when you have reflection off of a lake or a ski slope covered in snow, most of that reflected light is horizontally polarized. So it has a larger horizontal component than the other directions. And so by having those sunglasses that are vertically polarized, they essentially block all of that glare. I know when I ordered a new pair of sunglasses last summer, and the young woman at the optician was saying, well, now, do you want to pay the extra $90 for these prescription sunglasses to be polarized? And I said, absolutely. She said, well, it's a lot, but it makes a big difference. And I said, I fully understand it makes a huge difference. Best pair of sunglasses I've ever had. So they do make a difference. Okay. So we understand what happens. A filter essentially blocks out all of the light that is not in line with the polarizing filter. Okay, so if we have unpolarized light through a filter, our new light I is going to be exactly 1/2 of I0, where I0 is the original amount of light that was being transmitted. It will cut the intensity of that light exactly in half. The other thing that we want to understand is what happens if we have linearly polarized light through a filter. Okay, so if I have light, what's misspelled right there? If I have light that's already been polarized and I filter it through a polarizing filter, then I'm going to get this much through. It's going to be whatever the maximum amount intensity was, cosine squared phi. Phi is the angle between E, that's the direction of the linearly polarized light, and what we call the axis of the filter. All polarizing filters have an axis along which they are polarized. We can see if we take two polarizing filters, one horizontally and one vertically, and if I had some of my props, I could show you this. We can block all light. So if I have a polarizing filter that's vertically polarized, and then another one that's horizontally polarized, absolutely no light will get transmitted. If I lined them up where they were in the same direction, they could act essentially like one filter, and half the light would go through. Let's think about this. So I have I0, which is completely unpolarized. I go through the first filter, which is vertical, and I get 1/2 I0, and it's vertically polarized. If I take that and I put it through a second filter, so now I have 1/2 I0, and I have a second filter that is horizontal, well, let's use our formula. It says our new intensity, I, will be whatever our maximum intensity was, which in this case is 1/2 I0, that's how much is going into the second filter, cosine squared. Well, the angle between vertically polarized and horizontally polarized is 90 degrees. We know cosine 90 is 0, and that intensity will be 0. It effectively completely blocks all of the light. I need to take this. I'm so sorry. I'll get back. Hello?